Okay, in this video, we are going to look at simplifying radicals other than square roots again. We already did this in one video, but it was such a new concept, I felt like we should do it again. Okay, let's start off with this one. This time we've got a cube root. We've got this little 3 right here. So that means when we do our circles, we need 3 numbers in each of our circles. All right, let's divide this out. It ends with a 5, so I know 5 will go into it. 5 goes into 13 2 times with 3 left over. 5 goes into 35 7 times. 27 I recognize from my times tables is 9 times 3. And 9 is 3 times 3. Okay, let's cross out all of our numbers that are composite so they don't get in our way while we're trying to make our final answer. And I see right here I have 3 3's that I can put in a circle. Cube root, 3 things in the circle. Okay, so now let's write our answer. 3 is going to go on the outside. The circled things always go on the outside. 5 is going to go on the inside. Notice I had to put that little cube right there. If I don't put that, I'm going to get a square root instead of a cube root, and it's going to be wrong. Okay, let's look at our variables. So when I have a cube root, what do I divide by? I divide by 3. Whatever this number is what I'm going to divide by. So 3 goes into 3 one time with none left over. All right, so from what we've done in the past, which one of these numbers tells us what our exponent should be on V? Right, the one on the top. So I'm going to get V to the first, which I can put the 1 or not put the 1. It means the same thing. This one tells me how many are left over to go inside, which is none. Okay, so I'm done with V. Let's do Z. So I'm going to divide 11 by 3. 3 goes into 11 3 times. 2 left over. All right, this one tells me how many go in the numerator. How many go on the outside. This one down here at the bottom tells me how many go on the inside. And remember, when it's a cube root, the sign that's on the inside is the sign that comes out. I do not want to put absolute value bars on this. I just want to match it to this one. 135 is positive, so 3 is going to be positive. So that is our final answer. 3VZ to the third times the cube root of 5Z squared. All right, let's look at this one. So again, I've got that cube root right there. So I want to do 3 numbers in my circles. All right, 112 is even, so let's divide by 2. 2 goes into 11 5 times with 1 left over. 2 goes into 12 6 times. I recognize 756 from my times tables as 7 times 8. 7 is already prime, but 8 is not, so we'll keep going here. Okay, now it's a cube root, so how many numbers should I circle? I should circle 3 numbers. And also cross out all of my composites so they don't cause me problems later. All right, so let's see what I've got. Which number goes on the outside? The number in the circle goes on the outside. So 2 on the outside, and on the inside, I'll multiply back the ones that are not circled. 2 times 7 is 14. Okay, what did I forget? Right, I forgot the little cube root symbol. I can't start with a cube root and end with a square root, so I got to put the cube root right there. And look, this 112 is negative, so that means the number that comes out is also going to be negative. And I'm going to put a negative symbol right there. Well, now when we were doing square roots, that became an I. Why is it not an I here? Okay, well, you have to remember, I, by definition, is the square root of -1. I only goes with square roots. I does not go with cube roots. So when I have a negative with a cube root, I do not put an I. When I have a negative with a cube root, I bring it outside. All right, let's do our exponents. This is a cube root, so what should I multiply by? I mean, what should I divide by? I should divide by 3. All right, let's do that. 3 goes into 7 2 times with 1 left over. All right, so which one of these tells me what exponent should go on B on the outside? The 2, the number on the top. So I should have B squared here on the outside. This one at the bottom tells me how many are left over to go inside, which is 1. And then right here I've got C. What's the exponent on C? Well, that's an understood 1. When there's nothing there, it's understood to be 1. And will 3 divide into 1 a whole number of times? Nope, 1 is too small. So C is just going to go back on the inside. So there's our answer, negative 2b squared times the cube root of 14bc. All right, let's try this one. This one changes a little bit because it's a fourth root. So how many do you think are going to need to go in our circles? Right, I'm going to need to have 4 in the circle. So let's see, 625 ends with a 5, so I know 5 will divide into it. 5 goes into 6 one time with 1 left over. 5 goes into 12 2 times with 2 left over. 5 goes into 25 5 times. All right, that one still ends in a 5, so I'll try 5 again. 5 goes into 12 2 times with 2 left over. 5 goes into 25 5 times. All right, 25 I've memorized, so I've got that. Now, I need 4 numbers in my circles. Let me cross out the composite ones. Circle what I have there. How many do I have left? Well, none. I've used up all the prime numbers. Turns out 625 is a perfect fourth number because it's 5 times 5 times 5 times 5. So 5 is going to get to come outside, and so far we have nothing on the inside. Now let's do our exponent. If this is a fourth root, what number do you think you'll divide by? Well, you'll divide by 4. 4 divided by 4 is 1. So I'm going to get g, or g to the first, on the outside. And there's no remainder when I divide 4 by 4. So that's the answer. This one was a perfect fourth problem because the fourth root of 625 is 5. And the fourth root of g to the fourth is g. So nothing left over on the inside at all. All right, let's try this one. Now we've got some numbers on the outside with the cube root. Okay, so we need to do our factor tree. Which number should I put in the factor tree? Right, it's the one on the inside that goes in the factor tree. So 72, that's 8 times 9. 8 is 4 and 2, 2 and 2. 9 is 3 and 3. All right, now let's cross out all of our composite numbers. No getting mixed up. All right, now let's see what needs to come outside. I'm doing a cube root, so I can only circle groups of 3. Here's a group of 3 right here. 3 2s. So that means 2 can come on the outside. And the ones that are not circled multiply back together on the inside. So 2 on the outside, 9 on the inside. Hey, I forgot something. What did I forget to write down? Yep, I forgot my little 3. Don't forget to make it a cube root. If you start off with a cube root question, you need to end up with a cube root answer. All right, let's do our variable. When this is a cube root, what number do I divide the exponent by? Right, I'm going to divide by 3. So 3 goes into 5 one time with 2 left over. So that means I have 1 e that's going to come outside, and I have 2 e's that are left inside. Okay, there's a couple things we still need to take care of. I see in my original problem that I have a negative right here. Well, when I have a cube root, remember whatever comes out matches the sign of this. So I'm going to put a negative on that. And also totally ignore the negative 3EQ. Well, think about what the way this is written. Negative 3EQ times the cube root of negative 72e to the 5th. So that means I need to multiply this times 3EQ. That when it's written right next to each other like it is right here, it means times. So I need to multiply. So I'll multiply the number I already brought outside by the number that was there to start with. So negative 3 times negative 2, positive 6. E times E is E squared. And I've got a Q. Now that 3, can I distribute it over here to the 9? Nope, because this one is outside the square root and this one is inside the square root. They don't multiply together. Also, you don't use the distributive property when you don't have plus or minus. You need to have a plus or a minus in here to be able to use the distributive property. So I'll just bring down my cube root of 9e squared, and then we're done. There's our final answer, 6e to the second q times the cube root of 9e squared. All right, let's look at this next one. Same idea, only this time I have a fourth root, which means how many numbers am I going to have in each of my circles? Right, I'm going to have 4. All right, so let's see. This one ends in a 5. So I know that 5 will go into it. 5 goes into 40 8 times. None left over. 5 goes into 5 one time. All right, 81. That factors into 9 and 9. And each of those 9s is going to factor into 3 and 3. Okay, so let's cross out our composite numbers. We don't want them getting us mixed up when we get ready to write our answer. Okay, what do we need to put in the circles? We need to put 4. So I've got 4 3s in my circle right there. So now think about what the final answer to this part, not looking at the 5t right now, but just looking at these numbers. What's going to be the answer on this part? What's going to go inside and what's going to go outside? All right, the circled numbers go outside. The numbers that don't have partners, they have to go back inside. All right, and what do I need right here? I need that little 4 because this is a fourth root. All right, now let's do the variables. 4 does not go into 3 an even number of times at all, so t to the third stays in there. 4 into 14, let's see what we get. 4 goes into 14 3 times with 2 left over. So that means that the exponent on 14, the exponent on s, is going to be 3 on the outside, and it's going to be 2 on the inside. Okay, no negative this time. We don't have to worry about a negative, but we do need to do something with that 5t. Okay, so remember, what does it mean when they're written next to each other like this? It means multiply. So I'm going to take this, and I'm going to multiply it by 5t. Okay, so let me get a little bit extra space here. Get rid of my division. All right, 5 times 3 is 15. S doesn't have anything to multiply with. T doesn't have anything to multiply with. Oh, I didn't get that exponent in there very well. Sometimes it's hard to aim with just your finger. There we go. And then I have the fourth root of 5t to the third, s to the second. All right, so that is going to end up being my final answer once I multiply the 5t that was on the outside by the 3s to the third that's coming outside now. Okay, last one. This time it's an 8th root. Wow, we haven't done an 8th root. So what do you guys think? If a square root has 2 numbers, a cube root has 3 numbers, a fourth root has 4 numbers in the circle, what are we going to get for 8? I think you're right. I think it's going to be 8 in the circle. So whatever this factors in to be, and I'm not going to divide it out, but whatever it factors to be, I would need 8 numbers in the circle. All right, because that's going to match this 8 right here. And also, when I go to do my exponents, what do you think I'm going to divide by? Again, I'm going to divide by 8. We're going to use that again. So I'm going to draw another circle and put it down here. Divide exponents by this number. Because it may be that you have 3 or 4 like we've been doing. It may be that you have the 12th root or something. Whatever that is out there, you divide the exponent by this number. So that tells you, that number is really important. It tells you how many numbers go in each of your circles. And also it helps you know what to divide the exponents by to figure out the answer to that. And then once I do that, I'm going to multiply by this that's right here. So whatever I get when I do the inside, I multiply it by what's on the outside.